Sleep involves a sharp structural shift in your biology. After moving through initial rest stages, your brain enters a state of intense, highly organized activity. For the first hour of the night, your brainwaves oscillate in slow, rhythmic patterns. But then, a sudden and chaotic explosion of neural electricity fires across the cortex. This is rapid eye movement, or REM sleep. During this phase, your brain consumes the same level of metabolic energy as it does when you are wide awake. Simultaneously, the brainstem actively inhibits motor signals to your spinal cord, locking your physical body into total paralysis. Biologists have long struggled to explain why an organism would expend massive amounts of energy while entirely paralyzed and vulnerable. This expenditure reveals that dreaming is an active, parallel state of consciousness that requires significant biological resources to maintain. Historical attempts to decode this state began with the phenomenological tradition of the late 19th and early 20th centuries. The classical psychoanalytic approach treated the dream as a cipher, analyzing the subjective meaning and symbolism hidden within the fragmented narratives. Sigmund Freud categorized these visions as the mind processing day residue, the leftover fragments of daily experience and repressed desires. Carl Jung expanded on this, describing the compensatory function of dreams. He argued that the unconscious uses emotional, pictorial language to balance the one-sided perspectives of our waking minds. This subjective focus eventually met the modern neurobiological tradition, which emerged alongside advancements in measurement technology. The invention of the EEG and the sleep lab allowed researchers to finally measure the physical brain during sleep. Modern researchers, including Alan Hobson and Matthew Walker, began analyzing the mechanics of REM sleep rather than searching for hidden meanings in the narrative content. These two lineages, the subjective and objective, represent two different ways of observing the same system. Neuroimaging suggests that classic dream symbolism is simply the experiential side effect of the brain metabolizing emotional memory. To understand why dreams feel unguided and emotional, we have to map the specific neuroanatomy of the dreaming brain. The REM state possesses a very specific signature, defined by the localized activation and deactivation of cortical regions. This neurological map explains the mechanics of the dream state. The limbic system, the amygdala and hippocampus, hyperactivates, driving raw emotion and memory. The visual association cortex fires up, generating imagery without optical input. Crucially, the dorsolateral prefrontal cortex, the seat of logic, undergoes profound deactivation. When you combine an active emotional center with a deactivated logic center, the brain generates intense feelings but lacks the executive capacity to organize them rationally. This is the basis of the activation synthesis hypothesis. The higher brain struggles to weave random emotional signals from the brainstem into a coherent story. Bizarre dream imagery is the mechanical result of a brain processing intense emotions while its logic center is offline. This specific neural architecture is what creates the subjective phenomenon of symbolism. Clinical data on memory consolidation shows that the sleeping brain strengthens emotional memory traces and integrates new experiences with older knowledge. Because the brain's language and logic centers are suppressed, it connects these memories using associative visual metaphors instead of linear thought. This maps modern neurobiology onto classical psychoanalysis. Freud's day residue matches episodic memory consolidation. Jung's compensatory function reflects the brain resolving daily stressors, and Matthew Walker's research shows this mechanism works overnight to strip traumatic memories of their emotional charge. However, if dreams process personal memories, we must account for why certain symbols, like falling or being chased, appear across all cultures. Evolutionary threat simulation theory suggests that these specific nightmares are hardwired ancestral patterns designed for survival rehearsal. These hardwired survival patterns only make up 10 to 20% of our total dream content. The remaining 80 to 90% consist of idiosyncratic fragments unique to your own personal memory. Dream symbols are a functional, mechanical tool for regulating emotional load and rehearsing survival. Lucid dreaming challenges our understanding of the paralyzed REM state. This is a boundary state where an individual gains conscious awareness that they are dreaming while remaining physiologically asleep. From a neurological perspective, this shouldn't happen. Higher-order cognition requires an active prefrontal cortex, which is typically suppressed during REM. Lucidity is a hybrid state where the prefrontal cortex unexpectedly comes back online while the REM architecture remains active. Sleep scientists prove this experience exists using objective physiological metrics. Because the eyes are the only muscles not paralyzed during REM, dreamers use pre-planned eye sweeps, looking left-right, to signal researchers from inside the dream. Lucidity proves that the REM state exists as a fluid spectrum of consciousness that can potentially be manipulated. Modern clinical trials are now testing interventions to influence these states, specifically through targeted memory reactivation, or TMR. These boundary states are now tested in environments where neural activity can be tracked in real time. In a 2024 study, subjects performed mindfulness tasks while awake, each paired with a specific ambient audio cue, to create a mental link between the sound and conscious awareness. Once the subjects entered deep REM sleep, researchers softly replayed those exact audio cues. The data shows that the audio cue reactivates the waking mindfulness context, which can trigger the prefrontal cortex to boot up mid-dream. This reactivation allows the sleeper to regain higher-order cognition without waking up. Subsequent eye tracking data confirmed that these subjects achieved conscious control over the dream narrative. Dreams are a functional neural architecture that can now be influenced through precise clinical intervention. Understanding these mechanical tools allows us to consciously navigate the dream state.